Hi, welcome to the episode 3 of Code Review. Today we are going to dive into the core of our chatbot. We will take a look at the database system. We'll see how the database are created, the tables are created, and the schema for the database tables. We will take a look at the code for custom actions, specifically the constructor for our central custom action, which is the multiplication table challenge action. We will see how it actually interacts with the database and create the necessary components in order for the chatbot to function. So let's take a look at the demo.
Let us begin with the demo. Today we will be looking at what data are we persisting as we run custom actions. For that, we look at our database. So on my screen right now, you can see an interface to our data store. And we use PostgreSQL as our data store. Let's take a quick look at the events table. This is the events table, and right now it's empty, and the reason it's empty is because I deleted all the records, so we can start fresh as I do the demo, and you can see new events getting added once we start running the chatbot. So the events table, it's actually the data store for the tracker store, right? The tracker store here, and this is actually a table that if you decide to use SQL as the tracker store, it will actually create this table by Rasa will create it by itself, so you don't have to do anything with it. As long as you've defined it here that you wanted to use SQL as a tracker store. By default, Rasa uses the computer's memory as the tracker store, but if once the process is terminated, the events also are all deleted, so you have no record of the events that happened to the chatbot. So we wanted to use some sort of persistent storage. You don't have to use SQL. You don't have to use PostgreSQL. With Rasa, it actually comes out of the box, allows you to use MongoDB or say Redis. I actually prefer MongoDB for things like events, right, for the tracker store. But the reason why we are using PostgreSQL is because I think for the other purposes, for data that we want to store, and you will see that for data that we want to store for the custom actions, I think relational database makes more sense, and rather than something like NoSQL. But for events, I actually think MongoDB would be a better choice. But I don't want to manage two data stores, so that's why I just use Postgres for everything. But you don't have to do that. You can, if you have more people or you like database, you can use separate database for different things. All right, so let's take a look at the human table. And I know that the name human sounds funny because I think it is funny, and perhaps I'm trying to be funny. I don't know. It's actually, a usual name for a table like this would be like a user, or user would be probably be a more frequent choice. But I use human here is because this is a chatbot, and chatbot talks to human, and so I think this actually in this context, human is a more interesting name. And you can see that for humans table, we actually have a field for the Facebook ID, and for first name, last name, and the rest are pretty standard: create, time, and ID. ID is the primary key, right? So again, this is just the beginning of a pet project. There's not a lot of information that I need, so let's just start from here, I guess. The other table I want you to see is the challenge table. And when a person or a human finish or completes a challenge, I'll keep the score here. Time is how many seconds does this human take? Did this human take to finish this challenge? human ID is the ID that is the foreign key, pointing back to the human table. And yeah, so the others are pretty standard in create time, and the primary key is the ID. So, okay, now let's take a look, see what happens when you run a chatbot. And today we'll just run the chatbot directly from shell, rather than like 2 previous episodes when I used the actual mobile app. I think this is actually just easier, and and I think it's actually more clearer of what's going on. So now this is on this bottom left terminal is where I'm interacting with a chatbot, and bottom right is just the logs coming from the action server. So let's see what's going on. Okay, if I type hi, and it asks me, "Oh, are you ready for multiplication table challenge?" So let's take a quick look at what happens. Let's go back to the database and take a look at the events database. And you see, it was empty, but now the table is empty no more. The place where I want you to address your attention to is this type name, meaning action here, and action name is other challenge, right? This I here you see other events. They're not. I mean, they are important, but not our focus right now. We're actually focusing on this action called other challenge. And where does that come from? It comes from here. So if you go to stories, and so when I said hi, right, it actually is classified as a greet intent, right? So it identified it as a greet intent, and let's go back to how it identifies it. See if I could find the file. I think it's in nlu.md here, right? So so in this greet intent, you see some examples of what a greeting looks like, and hey, hello, hi, and hi. That's what we did. So it identified itself as the identified this utterance as the greet intent. And let's go back here. And if you recall, in episode 1, we talked about policies, and one of the policies is called memoization policy, which tries to match exactly to one of the stories here in the stories.md, and it matches the intent here, greet intent. So and this is basically a story, right? That start with greet intent. There's a couple more that because based on what I will say next, it could go on to another path, right? For example, I could when they ask me, do you want to start the multiplication table challenge, I could say no, right? But anyway, for those stories, right? It actually in the first action, it actually matches it, right? So now we have the greet intent here, and based on memoization policy, it invokes this other challenge, right? And that is this one, other challenge. And what is other challenge? Other challenge is, I believe, is in domain, right? Other challenge. Where's other challenge? there, right? So other challenge basically others the text ready for the multiplication table challenge, and this is exactly what you see here. And if I type yes, right, and if we go back to our stories, it continues on with the affirm story, right? Because I said yes, which matches the affirm intent, and therefore, based on memoization policy, it executes the action multiplication table challenge. And let us see if we can actually see that here. And you see that here, action multiplication table challenge here. And this will actually go into our custom action code in which it produces the question that we see here. 2 multiplied 9 is equals to 18, right? And then it will just continue to go into the multiplication table challenge. Actually, let's take a look at that. So how that works is it actually matches the NLU here. It matches, I believe, somewhere down here. It matches this one, the integer answer, right? It uses regular expression to match it, the integer answer intent, and it matches the answer intent, and in the answer intent, it puts in bracket that this thing is actually an integer answer, and the integer answer is defined as the regular expression here, right? So it matches the answer intent, and so let's see what happens in stories, right? Here, this part, if it matches answer intent, and based on the memoization policy, it calls on the action multiplication table challenge. Again, so it goes back to the same custom actions, right? And the same custom action actually produce another question. And let's answer it. Okay, let's just finish this challenge and see what happens. And by the way, I want to show you here is that if I go to the challenge table, and if I do here, have it show all the rows, you'll see that this is still empty, right? Nothing has been written to it. And if you look at the human table, nothing. Yeah, it's still empty, right? So you'll wait till we finish the challenge, and then you'll you'll try to add to the challenge table, but it realized that it couldn't really find the the human who was doing the work, right? So it needs to also add a record into the human table, right? So let's do this quickly. You can see that when I run this, it's much faster than when I run it on the app. Oh, now I've completed the challenge, and you see here it says my score 20 is 20 out of 20. Your time in 3 minutes. Yeah, I didn't really take 3 minutes because I was talking. My record time I remember back in grade 7 was like something like 18 seconds for like 20 simple multiplication challenge questions. But anyways, that was then. It is now. I have to admit that my math isn't as good as when I was a student. But anyway, what I wanted to show is this challenge here. Oh, let's take a look at human here first. Right? So, you see? Now, you see an entry here the Facebook ID is this, first name, and this person's Facebook ID, which is me. First name is Eugene, last name is Lin, blah blah blah, create time, ID, and so hey, yeah, let's remember this ID is 4. Okay, yeah, just keep that in your head, and then let's go to the challenge table. Right. Okay, so you see that the score is 20, so I got 20 out of 20. The time is in seconds, right? So 234 seconds. It's like 3 minutes and something seconds. And remember, I said let's remember the ID from the human table. It's because our foreign key is here, right? 4 actually refers back to the human table, the primary key there. Right. So now you see that my interaction, and let's take another look at events table. You see that my interaction with the chatbot actually stores data, and you see what data we're storing. The most important ones here actually, and in a minute we're going to go through, is the human table and the challenge table, right? Human table and challenge table are tables that we actually create in our code. The events table actually just comes out of the box with Rasa. All right, so that is our demo. So now let's do the actual code review. From where we left off in the demo, we saw that the action multiplication table challenge custom action gets invoked. And how that happens is that we actually followed the storyline of the story here. We started with hi, which matches the greet intent. And also I want to make a note here that if I say hi, it also matches the other storyline, which is the deny scenario. But it doesn't matter, right? Because for both of them, they both start with matching of the greet intent and execution of this other challenge. And this is what you see here, right? The hi matches the greet intent, and then when it executes the other challenge action, it actually utters this sentence: ready for multiplication table challenge? Now, my answering of, actually not this one, this is actually another example, but my answering of yes, it's actually way back here. My answering of yes, it matches the affirm intent. But if I answer no, it'll match the deny intent, and the memoization policy will actually switch to this scenario here. But because my answer is yes, we are still here, and it invokes the custom multiplication table challenge. Right? One thing I actually want to make a note while we're here is that the memoization policy tries to matches to its best ability one of the stories, one of the scenarios that we define here, right? And the way that it matches it is they look at the intent, and the intents are matched based on NLU.md. So for example, if I say hi, hello, hey, it'll match the greet intent. Right? And you saw the affirm intent being like when I answer yes, of course, for example, right? And you might think that this is, wait a minute, this is rule based, right? I'm actually defining all the rules. But no, that's not the case. These are training samples. These are training examples, right? So for example, if I go hi, oops, okay, hopefully I didn't change the code. Anyway, if I go hi here, right, it asks me, are you ready for multiplication table challenge? And let's say if I go, I've never done this before, but let's see what it will do. Absolutely. Right? For absolutely, it actually goes into the action multiplication table challenge, which means that it must have matched the affirm intent. But look, in where is it? Affirm. I don't have any absolutely here in my example, right? If it's rule based, it must have matched one of these. But absolutely here, it's not in any of these are examples, but if you think this is a rule based, it's not in any of the rules, right? So when I actually responded with absolutely, right, it uses the model to determine that a very high probability that absolutely actually belongs to affirm class, right? The affirm intent. And thus, it comes back saying, yes, this is a affirm intent, and thus, it will follow the storyline here and triggers the action multiplication table challenge. So this is a very important concept in RASA, that this is actually a machine learning model that it's running, right? It's not rule-based. It's based on machine learning, and you can actually define how you would like to do the matching based on the policy. Right now, we're using the simplest form using the memoization policy. And actually, I think we're also using the, where is it? Yes, we are also using the Keras policy, which use actually deep neural network, use recurrent neural network, LSTM to be more precise. Anyway, going back to the code. So today, for the actual the real code review part, I want to review this action.py file. And I won't review everything because, as you can see, this is actually a big file, and I will only sort of go through the beginning part of this this file to outline what the file looks like, as well as the constructor for the custom action for multiplication table challenge. Right. So one thing to note, if you actually follow along and actually looking at the code, this is not the action.py that's in the working directory, right? This is actually one directory down in the actions directory. So if you look at here, okay. So this is in the actions subdirectory, right? There's another action.py here which comes by default, and see everything is actually commented out. I'm not using this one. I want to keep everything in the actions folder. Where is it? In the actions folder, right? So I can keep all my related files under the same folder, so it's easier to manage. All right. So for the actions folder, the actions file, right? We start with very typical Python code with import of the required modules, classes, objects. Later you'll find out I'm actually doing another import inside the constructor, and the reason is because that's the only the object that gets imported is the only place where it's being used and to manage the scope, and because Python allows us to do that, and that's where I do it. But for more of a general import, it's usually here, and here I'm importing the Rasa SDK, action class and tracker class, because I'm actually inheriting from them. And one thing very important is that I also import rasa.utils, because I'm actually loading files coming from endpoints.yaml here, as well as a credential.yaml. I can't show you the credential.yaml, otherwise you'll see all my little secrets. So yeah, so and I'll let you know once we cross path with that lined up code. Right. So also we use cqualkme as the ORM, the object relational mapper. cqualkme actually takes a little while to get used to. At least for me, I find it somewhat awkward to start using, but it is very powerful and is by default used by Rasa. So I'm also using Squawkame here in my own code. Right. Yeah, and then just importing all the other necessities. Right. Starting the logger here. And right, so this is where I was talking about that, where I actually load values from endpoints.yaml and credentials.yaml. I can show you endpoints.yaml, which I think I already shown you in demo as well. That this is where the details of the tracker store information is, as well as where the action server is. And right, so I'm loading them into this these dictionaries so that I can use them later. Now, base is actually a class coming from Squawkame, and you use this base class to get information of the object tables, right? And we'll see them actually, they're just like right down here, right? It actually keeps track of that. And this is pretty standard way for Squawkame. If you look at many examples online, they're all the same way. So yes, it's a little bit weird, a little bit awkward, but they're all the same. So it's basically a copy paste effort. Yeah, to be honest. Anyways, and so this class here and these two classes, the human class and the challenge class, they actually represent the table that you saw in the demo part, where this class represent the human table and this class represent the challenge table, right? Oh yeah, and then they inherit from this base class. And yeah, we'll just quickly go through them. You saw the the Facebook ID, first name, last name, and create time for the human table, and ID is the primary key here. And for challenge table, you also have an ID, that's the primary key. You keep the score, the amount of time the person took to finish, or the human took to finish the challenge. Create time, pretty standard. And oh, one thing very important here is that you are saying that this human ID here, right? It is a foreign key pointing back to this human table, and that's what this is. And it actually refer back to the ID here. Yeah, ID here, right? That's human.id. So here, basically, you just define the object that represents, or the classes that represents the tables for your data store. All right. So now we'll go to the custom actions, and we'll skip this action reset for now and go directly into action multiplication table challenge. Right. This reset is also pretty important, but we'll do this in a separate episode. So today, what I want to do is simply just walking through the constructor for the action multiplication table challenge class, and it inherits from the action class, and for it to be a custom action, it must define the name method so that Rasa can use it to know what custom action this is. And for the constructor, I actually expect you to have some programming experience with Python, specifically in object-oriented programming. But if not, no worries. I will add a few references in the notes so that you can learn about object-oriented programming in Python. But for Python, the constructor is this thing, the thunder init. Thunder represents for double underscore. And this is the constructor. And for object-oriented programming Python, something a little bit different from the other languages is that the instance variables are not defined as a variable outside of the of the constructor. So normally for something like Java or for any other OOP, right, under class declaration, and you would that's where you'll define your instance variables, your class variables, right? But instance variables in Python actually is defined within the constructor. Specifically, it's defined like this, right? It's defined like self dot something. That something is your instance variable. Okay. Okay. So here we simply just this is where I was talking about, where I actually do the import here. This URL class. We import this class here because this is only being used in the constructor, right? And the URL class and eventually the URL object actually defines how you connect to the database. So keep a note of this, and we'll come back to the URL object. We logged some of those keyword arguments, the KWARGs, from the tracker store, so that in debug mode I can actually see what the values are. And so here from those keyword arguments, right, I actually assign the value coming from endpoint.yaml back to my local variables here, so that can be used later on in the constructor to connect to the database. So that is actually not very important here, but username, the login DB, the host URL, right, the name of the name of the database. So we load them here. Now here we actually instantiate the URL object, right? We import it back here. We actually instantiate an object here and assign it to a local object called the engine URL. And then with this URL, with this engine URL, where it has all the information from username. Oh yeah, so dialog is being used, so that's why, because we need it for constructing this URL object. But having this engine URL with a username, password, host, port, login DB, blah blah blah, the query, optional by the way. We create an engine, and the engine is what drives all the database interactions. Okay, so with the engine object here, we create the database. So what's happening is in this method, we'll actually see this method. Actually, this is actually defined within this class. You'll check whether the database is there. If not, you'll create it. So let's actually remember where we are here, but let's jump to this create database method quickly. Right? So it's right here, and using the engine, it tries to connect, and it tries to create a cursor to the database, right? And it checks to see whether the database where our chatbot is supposed to connect to does that exist, right? It does a select statement, and if it exists, so it tried to fetch a record from the cursor, and if it does not exist, then it tries to create a database. Otherwise, it just closes the cursor, closes the connection, and we are back to this line of code here. Now here, the engine URL, and in engine URL is this URL object. We'll tell it to use the database with the name that defined in the endpoint.yaml. So this will be the database name that we'll be using, right? And finally, remember the base class that we declared long time ago, like way above here, base class here. Now, the base class has a metadata class that actually stores all the tables object information. So we use that, we call it to create all the required database tables. Right? So here I have declared base class declared above has a metadata object which collects table object for table creation. And here we ask it to create the tables if they are not already created. Right? And the remainder chunk here is just exception handling. Right, so before we exit the constructor, we create a session object with a session maker, and it's based on the engine that we already created in the constructor. And basically, all the future interaction with the database will be built through the session object, right? So you'll see that if I search for session maker, I think in the run method, it actually, let's see. Okay, yeah. So in the save result method, which I believe then is actually being used by the run method, yeah, here, save result, where it actually saves the result of the users running the challenge back into the database. It actually uses the session. So we store the session here in the instance variable, session maker. Okay, so that's the constructor for the custom action multiplication table challenge.
Next week, we will take a detailed look at the run method of our custom action. The run method is the main logic for the interaction between the end user and the chatbot. It keeps track of the questions asked, and it generates the next questions. It keeps the score, and it writes the result to the database. I hope you will find it interesting to come back for another round. For today's episode, you will find below a link to the code on GitHub, as well as the notes on Google Doc. Please feel free to drop me feedback or questions. You can either leave comments below or fire me a message on Twitter. Thank you for watching, and see you next week. Cheers!